All right, guys, welcome to chapter 6. Just finished up chapter 5. If you haven't got that last bit of assessment in, please get it in. We're only going to do at most 3 more chapters, starting with this one. Chapter 6 is all about algebra and using formulas. If you're sick of how time-consuming it can be to graph and draw lines of best fit and stuff like that, you'll love this. It starts with really just the basics. I mean, 2x equals 4, solve for x. X equals 4 over 2 then, so that means x equals 2. I mean, that's the sort of thing we'll be looking at. If you have something like 2x squared equals, let's say, 8. X squared equals 8 over 2. So that means x squared equals 4. And then to finish it off, you got to do the square root of 4, which is 2. I do that right? Yeah, I think I did that right. So that is what you're looking at. I don't think I like writing in red here, so I'm going to switch my color. Let's see what white looks like on that background. Yeah, that looks cool, almost like chalk. So just to review collecting like terms and solving problems, this is stuff you've been seeing hopefully for some time. So what you do first is you want to move that 1 over to the other side with the 7. So we're going to have 2x equals 7 minus 1. So that leaves you with 2x equals 6. Then to get rid of the 2, you got to divide both sides by 2, and you end up with x equals 3. 6 over 2 is 3. So, it's that easy. Now I don't like having the white, so I'm going to switch to something else. Let's see how I feel about black. Circling things. Yeah, maybe that'll work for me. So you notice the title here in this review says collecting like terms. Well, we didn't have to do that. We just solved a quick equation there. And this one here, we do have to collect like terms. There's 1, 2, 3, 4 terms in this equation. And the things with the x's are like terms, and the thing without the x's are like terms with each other. So I'm going to get everything with the x over onto the left side and everything with no x on it over to the right side. So first things first, I'm going to take the negative 2x and I am going to move it over to this side. When I move a negative 2x over the equal sign, it's going to become a positive 2x. So I'm going to have 7x plus 2x instead of minus 2x. And I'm going to take that positive 3 on the left side and I'm going to move it to the right side. So I'm going to put my equal sign here. I've still got that 9. I haven't touched the 9. But I am moving that positive 3 over, which is going to make it a negative 3. It's subtracting 3 from both sides. 7x plus 2x is 9x. 9 minus 3 is 6. I end up with 6 over 9, which is 0.67, but we can just leave it as 6 over 9, or what would that be, 2 over 3 if we want it in lowest terms, not that it says that we need to do that. And that's how a question like that goes. That's called collecting like terms, putting them together and solving that equation. These are some of the skills that you're going to need to do this. Now, some of these pictures, I don't know why my phone didn't focus on these. I guess my phone's getting a little old. So this picture here of this formula I want to use looks a little suspect. But you'll just have to bear with me. It's C equals AG on top over G plus 12 on the bottom. And then there's just a period that we can just ignore. So this formula is being used to calculate a child's dose of medicine based on an adult dose. All right, so C is the child's dose in milligrams, G is the child's age, and A is the adult dose in milligrams. So it says, suppose the adult dose is 600 milligrams, calculate the dose for a 3-year-old child. So this whole first section is just about using formulas, which we've been doing, honestly, a lot in this course already, so it shouldn't really challenge you very much. So I'm going to substitute into this formula. So the adult dose is 600 milligrams, so I go 600, multiplied by the child's age in years. This is a 3-year-old child, divided by the child's age again, plus 12. So 3 plus 12. So this should be fairly straightforward, but you have to make sure that you don't try and punch all this into your calculator at once. You got to take care of that bottom first. You have to take care of the 3 plus 12, which is just 15. But if you try and punch this in as 600 times 3 divided by 3 plus 12, it's not going to come out right. It's not going to divide the whole thing by 3 plus 12. So on top, I'm going to go 600 times 3, which is 1800, I think. You guys can check that if you need to. And then on the bottom, I've got 15. That's the safest way to do it there. There are ways you can punch it all into your calculator at once, but it's not necessary. So I go 1800 over 15, and it's 120, and that'll be a dosage in milligrams. All right, makes sense. Less dosage for a child. All right, our next example, just again, it's solving a problem. Again, the formula pictures that I took aren't looking the best, but you'll have to just roll with it. Landscaper wants to estimate the cost of fertilizing a triangular lawn with side lengths of 150, 200, and 300. Right? Doesn't give you any angles or anything like that, so we really don't know. There's not a whole lot we can do with the conventional area formulas in order to do this, unless we were to draw like a scale diagram or something like that. But we're talking meters here. This is what we're going to do. So one bag of fertilizer costs $20 and covers 900 meters. That's supposed to be square meters. She uses Heron's formula, which I had to look up to determine the area. Here's the area formula here. A equals the square root of S times S minus A times S minus B times S minus C. These are the side lengths on the triangle A, B, and C. But what is S? S is this value that we can use that can be found going A plus B plus C over 2. So that's actually the first thing that we're going to do here. I'm just going to put equals, and I'm going to put those side lengths in. 150 plus 200 plus 300 divided by 2, and that's going to give me that S value. 150 plus 200 plus 300 equals 650 divided by 2 is 325. Again, be careful. You got to add that up at the top, and it gave me whatever it was, 650, I think. And then hit divide by 2. If I just type this in exactly as I see, it's not going to work. It actually will only divide the last number by 2. So it's 325. That's my S value. So I'm going to take that value and I'm going to substitute it into the area formula, which is the square root of S. So that's 325. I'm really going to have to extend this square root here because I got a lot of numbers to punch in. Bracket 325 minus A, and I said A is the first side, 150, minus 150. I'm going to extend this out, close my bracket, times 325, that's always my S value, minus B, minus 200, times 325 minus C, minus 300. So if you put all the brackets in, you can calculate this all in one shot, but I'm going to do it kind of the old-fashioned way here, and I'm going to figure out what each of those things is first. So I got 325, and I'm going to get a number here, and a number here, just to be safe, because I don't want to have to record this again without a mistake. So the first one, 325 minus 150 is 175. Next one, 325 minus 200 is 125. And then lastly, 325 minus 300 is equal to just 25. I'm still going to take the time and keep that square root sign there, and I'm just going to multiply those four numbers, 325 times 175 times 125 times 25, and it gives me 177,734,375. Ooh. Let's get that square root going. I'm going to hit the square root button, and it gives me a total area of 1,333.7 meters. I rounded that off at the end. Now, this isn't the answer to our problem. See, this is a long problem. I had to figure out the S value. I had to put all these numbers into the formula. I still need to figure out what the cost of fertilizing is. And I don't know if I should have kept that 1333 1.7. All right, I got that number in my calculator. I think I might have put a blank slide next. Let's see if I was smart enough to do that. Oh, just barely. And I've got 900 square feet can be covered with one bag of fertilizer. 900. Everybody remember that for me. So how many bags of fertilizer will I need to make to get my area covered of 1333 1.7? That is square meters. So one bag is 900 square meters. So I'm going to divide that by 900 square meters. That's what each bag can take. So I'm going to say that it's going to require 14.813 bags. And what did we say that the cost then? Well, there's a couple of ways you could approach this. I'm going to do it this way first, but then I'll show you the other way. So let's say it takes 14.8 bags times, what did the question say? $20 a bag. So I take that 14.8 and I go times $20, and it's going to cost you then $296.26. I don't like the way that 6 came out. There, that's better. So $296.26. However, you might think to yourself, well, just for reality's sake, what's 0.8 of a bag? Are you taking the rest of it home? Are you just going to use it all? Would you rather calculate the cost, let's say, with 15 bags? That might make more sense. Times $20. The question doesn't specify that you can't break it up like that. So if I wasn't more specific on an assessment question, I'd have to accept either answer, right? Either 300 or 296.26. Either way works for me. So that's how you can approach a problem like that. Let's give one more try. A landscaper uses a bucket with a radius of 18 centimeters by 18 centimeters, a height of 18 centimeters, and a radius of 18 centimeters to pour soil into a rectangular planter that is 1 meter by 40 centimeters by 20 centimeters. How many buckets of soil do you need to fill the planter? Well, when we're talking about amounts of soil, it's going to be a volume. So let's go volume of the bucket. I'm just going to put a B there for bucket. So the volume of the bucket is going to be a cylinder, right? Well, it's just, it's a bucket, right? So it's going to be a cylinder. And it says that the height is 18 centimeters. And it also says that the radius is 18 centimeters. Right, and if you remember, you got to find the area of the circle and then multiply it by the height from back in our geometry unit. So that's going to be pi r squared times the height. And in this case, they're all 18, so I'm going to go pi. I'm using my pi button on my calculator rather than 3.14, but it doesn't really matter. Times 18 squared times 18. And it gives me this nice big number here, 18,321.77 square centimeters. And I got to figure out how many of those it'll take to fill up the volume of what's the other thing? It's called a planter, right? And the planter is a rectangular prism, basically, which is just going to be length times width times height. So it's going to be that value times 40 centimeters times 20 centimeters. But just be careful, check out that 1 meter. And I didn't mention this before, but the title of this example is Converting Measurements. All right, because it doesn't matter really what the units are, but they have to be the same. If I calculate this one in square centimeters, if I'm going to compare it to the other one, I need it in, actually it's not even square centimeters, it's cubic centimeters. If I'm going to compare that, then I need this in cubic centimeters, which instead of 1 meter, I want 100 centimeters. So I go 100 times 40 times 20, and it gives me 80,000, 8123 cubic centimeters. Now I could have converted everything to meters and had smaller numbers to deal with, but since most of the measurements were in centimeters, I decided just to convert the 1 meter to 100 centimeters. That made the most sense to me. So this is how much fits in one bucket, and that's how much space or volume I have to fill. So how many buckets will I have to fit in there? Well, you just go 80,000 divided by how much fits in one bucket, 18,321.77. And I'm doing that right now, 80,000, 18,321.77 equals 4.4 buckets. You could round that any way you want, just over, 4.5. But my calculator gave me 4.4. I rounded it off to one decimal place, and I think that's good enough for the answer, guys. So that's the type of thing you're going to be dealing with today, just plugging numbers into formulas and getting answers. That's what you're going to be doing. All right. So for numbers 1, so this is on page 346, 347, section 6.1. So for numbers 1, 2, 3, 4, and 5, there's like an A through D or A through F or something like that. And I just want you to show me one from each, right? So I just said B. Do 1B, do 2B, 3B, 4B, 5B. And then there's a couple of word problems, just 3 of them, 6 on 6, 7, and 8. All right, where they're more like the questions that I did as examples for you today. So just plugging numbers into formulas and coming up with answers. I think this will be a walk in the park after what we've been doing. The other sections that are upcoming are just rearranging formulas, collecting like terms, some exponent laws. Like I don't even, if you got a squared times a squared, you add the exponents, it becomes a to the power of 4. So there's a whole section just on that we're going to do, I think, next week, next Monday or Wednesday. So anyway, good luck with those questions. Keep taking a picture when you're done and submitting them to me. You guys are doing great on that so far. Keep it up. We only have 7 weeks left of school. All right. I think that is going to be good for me. Good luck on the work. If I forget to post the pictures of the section in the textbook, just let me know. Give me a friendly reminder there and I'll get those posted. Okay. Good luck, guys. That's all for now.